Boom. All right. Oh, that's algebra 2 yesterday, my bad. Let's get those. All right. 14. LRAM. This is one of those that's really easy when they give you an XY chart, right? Because this is where you've got to put like the interval on the outside and then add some things up on the inside. What goes on the outside in this one?
4.
4.
Yes, 4, because it's however far apart each of the x values is, right? So time is kind of like your x, velocity is like your y. So since all those are 4 apart, 4 goes on the outside, boom, put it right there. And then if it's LRAM, we're either using the 0, 4, 7, 7, 11, 16 and not the 18, or we're not using the 0 and we're using the 4 all the way to the 18. Which one is LRAM?
0.
Not using the end.
Yeah, you use the 0 because LRAM is you want the left side. So use the 4, 0 plus 4 plus 7 plus 7 plus 11 plus 16. Squeeze it in there. And then you don't use that. So then it's 4 times whatever that is, 11 is this, and there's another 11. That's going to be 22, 29 with the 7 plus 16, 39, 45, 180. Is that what you guys got?
Yeah.
Sweet. So that one's pretty easy, which is nice.
Will it be that easy on the final?
Yeah, if there's an XY chart on the final for LRAM, RRAM, it'll be that easy. And the good news is, I mean, you get your calculator the whole time. So even if it's gross numbers, same process. So number 15, this is where, like, this is one of those weird ones. I want you to take all that gunk and just write an integral from it. Do you guys remember what goes where?
7 and 15 are the bounds.
Perfect. So that's the thing at the bottom there is the interval. That's the bounds. And then you use the integral sign instead of that ugly summation sign. And then that delta x is what becomes a dx. So then that basically, what is your function then?
What's in the parentheses?
2x plus x to the negative 2.
Right. You could either do this or, like Emma said, perfect, plus x to the negative 2. Basically, it's just wherever you see the ck, you replace it with an x. So that's literally, this is literally the answer for 15.
Oh.
Yeah.
So it
That
just
one-
wants to change the form.
Right. So they didn't even want you to evaluate it. I mean, we could use an int or otherwise, but actually in this case, they just wanted you to rewrite it.
Cool.
Yeah. I can tell you 16, 17, and 18. None of them are super hard, but it is like bringing it back, especially 16. There's going to be one almost exactly like 16 on the final. Like 16 is a big one. That's a good one to know. So it says, consider this thing. And it says estimate. Part A is going to be using RRAM. So we did LRAM with the charts. Now we're going to do RRAM. B is going to be trapezoid rule. Said you need to know trapezoid rule. Don't need to know simple rule though. I asked about that yesterday. And then integrate is actually just straight going backwards, like finding it. And you can use int to double check yourself, obviously. I think on these, I'll probably, if I want you to do it by hand, I'll say do it by hand and show your work, but you can double check yourself using int. You got that. So how do we use RRAM again if it says using 4 rectangles?
You have to, it's from 0 to 4, so it's just 1 per
Yeah.
rectangle.
Eli's totally right. 1 on the outside because it's from 0 to 4 and there's 4 rectangles. So you know each one of them is wide apart. If there's 4 rectangles, you know you're adding 4 things together. Now the question is, we don't have a chart this time. So like, how do we get these 4 things?
You just plug them
You
into
either
your doodle.
plug in 1, 2,
Yeah.
3, and 4, or you can just graph it and use the table.
Right. So you could graph it and use the table and just use the table. The main thing is that like we're looking at RAM, so we're not going to plug in 0, right, everybody? When we did the chart, we plugged in 0 through that thing, but we got to plug in 1, 2, 3, and 4 to this. Is that okay for everybody? Sweet. And so, yeah, use a table and double check me if you want, because I like that. If you guys want to, that's a great tool that Emma's saying. If she just like graph this function and then just go to the table function, make sure you're set at like whole numbers, but then it'll plug it in for you. But you guys can double check me. If I plug in 1, I get 1 minus 3 is -2 plus 5 is 3. If I plug in 2, I get 4 minus 6 is -2 plus 5 is also 3. 9 minus 9 plus 5 is 5. 16 minus 12 is 4 plus, is that what you guys get?
Yeah.
Yep.
And then you guys get 20? Cool. So yeah, that's going to be a good, I mean, this is like, the only thing I did not like about yesterday is I did not like how like, you're going to have like those increasing, decreasing questions, but I did not like how this review guide made them harder, like a really hard, crazy function. Like I'm going to give you something that's like a function that's normal, that you've got the ability to look at and be like, okay, I know what's going on. Kind of like this one. I mean, this is a perfect thing that could be on your final. It's a nice parabola, and you got to do RAM, you got to do trapezoid rule, and you got to do integration. So trapezoid rule, the main thing is, what is that again? Well, yeah, it's like h over 2 plus, you know, some things, and you got to add 2, like a 2 in here when you multiply or something. But isn't the h just the 1 from the other problem?
Yeah, I think.
Yeah, perfect. So it's just b minus a over n, which is like 4 minus 0 over 4, or basically just how wide things are. So this is going to be 1/2 times, and then instead of just doing the 4 rectangles, you actually do have 5 things this time, because you multiply all the middle ones by 2. So this is just a good thing to remember. And how do you get the things? I mean, you guys know this already, but how do you get the things that we're going to put in those blanks?
Plug them in.
Yeah, plug in 0, 1, 2, 3, 4, 5. So you do plug in all of them this time. You plug in 0, you get 5. So it's basically these same numbers that we had from before, except for I got to plug in 0 as well. And then you calculate that. Is that coming back to everybody?
Yes.
Yeah.
Sweet.
What does the n equal 4 in the wording mean?
That's a good question. So n equals 4 still just tells you that there's 4 rectangles.
Okay.
Well, in this case, trapezoids, obviously, I guess, because we're using trapezoid rule. But
36.
yeah, 36, and then take it times a half.
18.
18. And it should be similar to what we got for part A, right? It's just that RAM is the least accurate of these 3. Trapezoid rule is more accurate. And then my guess is we're going to get something that's a little bit different than both of these for part C, because part C is actually going backwards, right? And taking the integral, which is 1/3 x cubed minus 3 over 2 x squared plus 5x. And we've just done this a ton. We're plugging in 4 and 0, but 4 is awesome. It's not great, but 0 is awesome because it's 0. So what is that? 64/3 minus 40, because 16 divided by 2 is 8 times 3. 40 plus 20. 64/3 minus 20, but that's minus 60/3.
Wait.
That does not seem right. I did something
Oh.
wrong.
Where does
Three
the 40
halves.
come from?
Yeah.
It's 24. I
Pretty
think.
Oh, 24. For some reason, I thought that was a 5. Yeah, you're right. Good. Okay, I was like, that is way too big. 16 divided by 2 is 8 times 3 is 24. Got it. For some reason, I was taking it times 5. That's very bizarre. 64/3 minus 4. That's much better. And that's the same as 12/3. So 52/3.
17 1/3. Yeah.
And that seems much better. That seems very close. And that's the exact area. Again, that's a big hitter, and I can tell you guys this is another one that Kasky was huge on, and like there's one pretty much exactly like that on the final. How do you guys feel about that?
Yeah.
Sounds good.
Sweet. 17. I don't think it's a 5-part question or 3-part question like this, but there's definitely one probably like this, I think. This is where they give you some of that information and you've got to figure some things out. Like for part A, it wants the integral from -1 to 4 of f of x minus g of x, right? And so you just have to take the f of x1 minus the g of x1. So what did you guys get for part A?
7.
Boom. Love it. Part B, and if you guys remember, I actually gave you some trick questions of these on the quiz and test this chapter. I'm not going to do that on the final because like a trick question would be like f of x times g of x, because you're not allowed to do multiplication and division because integrals don't multiply and divide that way. That's why we need like integration by parts and substitution and that sort of thing. But you are allowed to add or subtract, so that's why this works. So then what's 3 times f of x plus 5 times g of x?
I got 5 for that one.
15. Yeah. Yep. I like that. And then part C is where we actually finally use the other one, from -1 to 1 of g of x. This is the toughest one, I think. It's not too terrible, but if from -1 to 4 of g of x is -2, and from 1 to 4, or no, yeah, that's right, of g of x is 3, what is -1 to 1?
Do you subtract them?
Like -2 minus 3.
Yeah, because you can think about it just subtracting them, or sometimes I think about this thing right here is the whole, right? Because it's from -1 to 4. So the whole's got to equal the 1 to 4 plus the -1 to 1. And this is the one that we don't know. So it's kind of like our variable, but this one is 3. So -2 minus 3 would be -5. Yeah, nice. How you guys feel about that?
Pretty good.
Sweet. Number 19 obviously should be pretty easy. You're just minting it, but my hint on number 19 is make sure that you just double check yourself. There is no reason in calculus that you should be in degree mode. And like if you were in degree mode when we minted 19, you would get the wrong answer. So I'll try to remind everybody of that, or if somebody wants to remind me to remind everybody, just make sure before you start your final that you're in radian mode. All right, if you've been doing physics or something, like switch it back to radian mode. Anybody want to say what they got for 19 so I don't have to plug it in?
I got like 7.4985, 7.5 basically.
Everybody feel good about that?
Huh?
I think I do have one of those. I could be wrong. Maybe I just have ones where I want you to show you where you're going to double check yourself in there. This is going to be a little weird. I'm going to do 20 and 22 before I do 21. Because 20 and 22, if you guys remember, this is the thing that I like my very first year of teaching calculus, I taught wrong. And it's that thing we really had to go over. So we'll do 20, and then if you're confused on one of these, then 22, hopefully you can kind of look at and get on your own. So remember, when it says derivative of the integral, right, those should cancel each other out, but what do you have to do actually, though?
Switch the t to an x.
You've got to plug whatever is in here right there. So this is going to be 5 minus 2x. And do you guys remember what we have to attach?
You just, I don't know.
2.
What's the derivative of 2x?
2.
Yeah, you got to attach that. So your final answer is this, or if you want to distribute, then you'd get 10 minus 4x. So that is something that really usually throws people, is they have to remember to attach. So derivative and integrals cancel each other out. You got to remember to attach. So why don't you guys really quick try number 22, and then just see if you can figure out which choice it is. So this is from 1 to, they say find dy dx. So they're essentially say find the derivative of this integral. Do the same thing that we did for the other one. Got a bunch of other places to plug it in though, and see if you can attach things and get the right answer. So did you guys get D?
Yeah.
Yeah.
Nice. Because you're supposed to put this in there and there. So you're going to get 3x to the fourth minus 5x squared. But then you do have to attach the 2x, derivative of x squared. So then you get 6x to the fifth minus 2x to the fifth. Sweet. Is that coming back to everybody?
Yeah.
Now that I'm actually like looking through this, I forgot that I had like cut like less problems off the beginning than I had done the end, just because there was things in chapter 7 that we didn't cover. So I'm actually feeling like really good. We probably won't go the whole hour today, just to make sure that if people want to join in tomorrow, because we'll be able to for sure finish the last two.
Tomorrow.
2 o'clock tomorrow. Okay. Yeah. Let's jump back to 21 though. And naturally, I mean, I think I should have just gone a little bit slower yesterday now that I'm like here, because yesterday's stuff was all the stuff from like that's farther back in our brains. Like now we're hitting the stuff that's more recent. And so it's probably, you know, fresher in our heads. Maybe I'll go back tomorrow at 2. I'll probably go back and do a couple of those really important ones again, like the limit problem and the increasing and decreasing problem, and maybe the sketching the derivative problem. Maybe I'll go back and do a few of those just to make sure we're feeling good on those important ones there. All right, so this is where, if it says like find the integral using the fundamental theorem of calculus, this is where like it's going to be a straight integral. I want you guys to show your work, but you can use int to double check yourself. So it does not bother me if you use int to double check yourself, make sure everything's accurate on your final, but show your work there, kind of like you would have on the last test. Negative pi over 2, or no, regular pi over 2. Pi over 2 to 5 pi over 6 of cosecant cotan. All right, let's see what we got. Let's start on part A. What's backwards from this thing?
X to the x cubed
Nice.
minus, oh my god.
6x squared
Yeah.
plus 4x.
Nice. -1, 3, and then we just got a bunch of things to plug in, which is gross, but hey, we don't have fractions. That's nice. 27 minus 3 squared is 9. 54 plus 12. And then we're going to subtract off what we get when we plug in -1, which is -1 minus 6 minus 4. So we are going to subtract off a -11, so that'll be plus 11. And over here, 27 minus 54, I think is -27. Plus 12 is -15. -4, is that what you guys get if you ninted?
I didn't know. I think that's the answer.
9.
How are you feeling about that one, everybody?
Good.
Sweet. All right, the next one, what's backwards from x to the 3/4?
So 4/7 x
Nice.
7/4.
Perfect. Yeah. 7/4 is up there, and then have to attach the reciprocal. And then from 16 to 1, I mean, this is a little gross, so you can obviously use your calculator, but because 16, the fourth root of that is 2, but then you have to take it to the 7th.
I want to say that's like 128, but I'm not sure.
I think you're right, because 32.
Yeah, I think so.
Yeah.
It is.
128, and so it'd be 4/7 times 128, which is really kind of gross. And then you'd be subtracting out what you plug in with 1 is at least nice 1, you get 4/7. So, yeah, that's still really not very nice. What I would probably do is pull out the 4/7 and then you get 128 minus 1. which is at least then you'd be taking 4/7 times 127. But I don't know if 127 is divisible by 7. My guess is it's not. It'd be really nice if it was. No, it's not.
The answer is 72.6.
Yep. Wait.
That's what I got.
Yeah.
So 508/7, which is 72.6. I like it. Here's just a good memory. What's backwards from cosecant cotan?
Lucy?
Negative cosecant. Nice.
That was close.
Negative cosecant. So, because cosecant's derivative is negative cosecant cotan, so that's positive. And then this is gross because we got to plug in 5π/6 and π/2. 5π/6 is here on the unit circle. So 1/2, but the reciprocal of that would be 2, but it's -2. This is a negative sign. Minus π/2. Sine of π/2 would be 1. But when you flip that, it's still 1, and then it's a -1. So -2 plus 1 is -1. If anybody wants to verify that, and then let me know, but I'm pretty sure that's right.
Ugh. How do you plug in cosecant and cotan into a calculator?
That's a good question. So what I would probably, I mean, there's a couple different ways. Cosecant is 1/sine. So I'd probably plug it in like that, use parentheses. And then cotan is either 1/tan or cosine over sine. It'd be really nice if they canceled. I'd probably use 1/cotan just so you have to press less, or 1/tan so you have to press less buttons. Probably what I would do. So I'd probably type it in. It'd be like the integral, you'd have to plug in these guys. And then these would probably both be in your parentheses. These would be x's, obviously. And they probably have their own parentheses as well, so that gets gross. And then dx. I'd probably plug it in like that.
All right. Because I feel like I always messed it up, and then I get like the wrong thing comes out.
Yeah, basically, I think you just need a crap ton of parentheses on that. So I apologize in advance, but that's gross. Good. Any questions on that one? I believe it's the last question of the final that looks like this. It's like it will let you use int to double check yourself, but it wants to see all your work of going backwards. So trapezoid rule with n equals 6 to approximate this. So let's see how you guys do. See if you can start to set this one up. Maybe you already have, I don't know, based on the fact that we already did trapezoid rule. So see if you can get what goes out front. See if you can get what goes on the inside. And then we'll plug it in and see if it all gets in. right, did you guys do 3 minus 0 is 3 divided by 6 is like each one's a half, but then that half has to be over 2. Cool. So you get 1/4 out front, pretty much is what you get. And then to get the insides, you've got to plug in 0, a half, 1, 1.5, or 1.5, 2, 2.5, and 3. Like you've got to plug in all 7 of these things. And e to the 0 is 1, but after that, it's literally just going to be 2 times e to the half plus 2 times e to the 1 plus 2 times e to the 3 halves. And so this is just going to be a really gross thing that you just have to plug in all of 2 times e to the 5 halves plus e to the 3rd. So anybody want to say what they get when they plug all that in?
I'm working on it.
Yes, and feel free to just give me the final answer if you want.
I got 19.5.
Sweet. We'll just let one other person confirm that. If you all feel good, then we'll keep going.
And then it just ends in a 1, right? Like, you don't multiply the last one by 2.
Good, right. You don't multiply the first or the last one by 2.
I got 19.5 as well.
Perfect. I'm feeling good. You guys feeling good about trapezoid rule?
Yep.
Sweet. So, moving to the next page. This is good. It's getting us into the last 2 chapters. So the last 2 chapters are what we covered remotely. So that's always good to go over as well, even if it is more recent. So 25. If it says evaluate the integral, do you guys know what it's actually asking you to do here? Oops.
Take the derivative.
Go backwards.
Derivative would be forwards, but
Antiderivative.
Antiderivative.
yeah, and then put your plus c on it. So like don't evaluate anything, just go backwards. So what's backwards from x to the 4th?
4. Oh. Bleh. 1/5 x to the 5th.
Nice. This guy is what?
4 times x to the -2, so then
Yeah, do that.
-4/3 x to the wait, that's the other way.
to the -1.
Yeah, so negative for x to the -1. So you wouldn't even need this plus sign in here because that would turn to a minus. Because you'd be dividing by 4 to by a -1. And then what's backwards from e to the 2x?
2e to the 2x.
That's forwards.
Oh,
Half of the 2x.
Perfect. And then plus c. So we're into the chapter where we had to use like q and u and dv, but notice on this one you didn't have to use any of those because there's no like product rule or chain rule. The good news is everyone, 27 I should have cut out because I don't have you guys do a slope field.
nice.
So we'll go on to 26, and because I didn't actually give you the graph with which to do that, so that would be a problem. So 27 then is, or no, 26, sorry, we're skipping 27. Put 26 first, is dy dx equals 3x minus 4 to the 3rd, and then y1 equals -1. If you guys see this, do you guys remember what you're doing?
You have to go backwards, but then solve for c.
Yeah. Perfect. So backwards is just y equals, ooh, this is kind of tricky. What's backwards from this thing?
4 to the 4th.
This whole thing to the 4th. And we're going to have to attach what out front?
1/4.
1/4 and actually something else.
And the derivative of the middle. So 3.
And
3.
1/3. Yeah, but we got to still make it 1/3 because we're going backwards.
Oh.
plus c. And then we want a negative 1.
I definitely just like foiled it because I couldn't remember chain rule backwards.
Wait,
That-
why one?
Yeah, if you've got time, you're like, what the heck is going on? Just feel free. Yeah.
Where'd the 1/3 come from?
So the derivative of 3x minus 4 is 3, but since we're going backwards, we can't attach a 3. We got to attach a 1/3.
Okay.
Yeah. So then this is, I'm going to plug a negative 1 in for y. This is 1/12. I'm plugging in a 1 for x plus c, but 3 minus 4 is negative 1 to the 4th is still just 1. So negative 1 equals 1/12 plus c, and you subtract a 12th.
So 11. Wait.
Negative 13/12.
Ew.
That's gross. But your final answer then is y equals 1/12, 3x minus 4 to the 4th minus 13/12, because that's what we found c to be. Well, that's nasty. Yeah, I double checked. No slope fields, friends. You know, as I'm looking through here, though, one more time, the one thing that is not on this review, I don't think, is like displacement, acceleration, all those things. So we're gonna have to do one of those at the end. So that'll be what we replace 27 with when we get there. But 27, just cross it off. There's not one of those. So there you go. 28. Let's roll. We're rolling on through so that tomorrow we can do extra stuff from what we rushed through yesterday. Use substitution. If you see use substitution, what's that mean?
Q.
Q.
Yeah, man. Perfect. What's a good Q?
Secant squared.
Tan X.
Ah, yes. Tan, because tan's derivative is,
Secant squared.
yeah. So like kind of identifying those things, but tan x is a perfect Q because dq is secant squared dx, and then I can solve for that. Now here's a little bit of the tricky part because this is in such a weird format right now. I'm going to put Q in for tan, right? So doesn't that just mean that this is root Q to the 5th?
Yeah.
But wouldn't it make more sense to just write it as Q to the 5/2?
You can do that.
Yeah. And that's what I would say to do, because then you've got a root and a 5th power that you're trying to deal with. So just do Q to the 5/2. That's what that is. And then secant squared x, but then dq over secant squared x. Those are going to cancel out like we want them to. So that's a little bit of a tricky part on that one, is just going there. Once you get there, you're probably good. What's backwards from Q to the 5/2?
2/7 Q.
7 halves.
Nice. So then your final answer is 2/7 tan to the 7/2 plus c. Now you're more than welcome to make that the 7th, like root tan to the 7th, but I would just say keep it like that. That was the one hard part about that one, I think. Sweet. Let's get through. My goal is let's get through 29 and 30, and then that leaves us with like only 6 problems for tomorrow. But what I'll do is I need to find one about displacement. And actually, you know what I might do? I might just add it to the end of this. I'll just type it in here quick at the end. I'll make a number 40 that's about acceleration, displacement, initial velocity, all that stuff. So I'll put one of those in there because that's on the final. That's the only thing. I looked through one more time. That's the only thing that's not on this review sheet that's on their final. So I'll put one of those on there. And then tomorrow we'll go through the last 6 or 7 questions. And then we'll go back and hit some of the heavy hitters from yesterday that we kind of had to rush through. So we'll hit like another limit one and another increasing, decreasing one, another sketching one, and that sort of thing. because I did feel like we had to rush through a couple of those yesterday, so I apologize about that. 29. Use separation differential equation by separation of variables here. So what do we want to move to the other side?
Y squared minus 2.
Yeah, man. It's gone. Y squared minus 2. And then I'll move the dx while I'm at it because that's going to come over here. So I'm going to have y squared minus 2 dy equals x cosine x squared dx. And then everybody remembers you taking integrals, right? Which one of these is easier to go backwards from this time?
Y?
Why?
Yeah, usually y is the harder one, but definitely easier this time on y. So what's backwards from y squared minus 2?
1/3 y cubed minus 2y.
Beautiful. The reason that the x part's looking so hard to me is because I think we've got to use either q or the u b thing. Which one are we going to use for this one?
I think you have to do integration by parts, but I also tried doing it and got stuck. So I don't know.
See, I'm glad that you said that. So integration by parts is what my brain goes to because I see the two parts. But I think this is actually q, because I think you would get stuck with that x squared in there every time if you use integration by parts. So what's on the inside of something here?
X squared.
X squared.
Yeah, and I think this is going to give it to us. dq would be 2x dx. And if I divide by 2x, then I'm going to have the integral of x cosine q dq over 2x. And then the x's are going to go away. And I can just pull the 1/2 out here and get rid of it too. And then I'm good to go. So yeah, that one's, I'm glad that you had said, Emma, that you tried integration by parts that got stuck, because that's tricky. So if you ever try one of them and you get stuck, go try the other one. That'll be the main thing on that. So now what's backwards from 1/2 cosine q?
1/2 sine q.
Perfect. And is it okay with you guys if I just put the q back in right now? And actually, they don't give us a point to plug in, right?
Nope.
Nope. So this is actually done. Woo. That was gross. And last one for today, number 30. Although honestly, 31 is the shortcut. I feel like we should end with 31 because it's the shortcut. Bless. So 30 is where you're not doing the shortcut. You're doing integration by parts the old school way. So let's just see if we can remember how to set this up. What would you guys use as your u?
X minus 5.
Oh, that'd be q. So now we're in u and dv instead of q.
Well,
X.
Yeah, remember, so u is something that you want to get simpler because du would just be 1, right? So that'll be nice. But then dv, like you pick out u and dv is kind of your job here. So dv, then you got to use whatever's left. Hopefully you can go backwards from it. What do you guys think? Can we go backwards from sine 2x minus 5?
Yeah.
Yeah, what's backwards from that?
Negative cosine 2x minus 5 times 1/2.
A half, good. So that's gross, but I think we got it. Sometimes I think we do the shortcut so much that we forget how to do like regular integration by parts. At least that happens to me. So then the formula to know, really the only formula besides like derivative integral formulas that you're going to need to know is this one. And trapezoid. Yep. All your derivative integral formulas, but then besides that, just probably this one and trapezoid is all you need, I think. I'll double check that one more time again, but since I've looked at the final again today. Feeling good about that. So UV would be x, I'm going to put the -1/2 out front, x cosine 2x minus 5, and then you're going to have minus the integral of v du, but this is just a 1, so that's really, really nice. So cosine 2x minus 5 dx, I'm going to pull out the -1/2, -1/2, and make that a plus. Actually, maybe I should do that in a different color so people know that I did it if they watch this. So plus 1/2, and get rid of that. Now, what do you guys think? Can we go backwards from this?
Yep.
Sure thing. Because there's no more product rule in there. Which is why this was so misleading that this one wasn't. Like, if you look back now at the prior problem, you're like, wow, this one should have been a UDV, but it's because it's got that x squared in there. So plus 1/2, but then what's backwards from cosine 2x minus 5?
1/2 sine 2x minus 5.
Nice. So I'm gonna make this plus c, and I'm gonna change this into a 4. Boom. How do you feel about that?
Great.
Excellent. Yeah, we're doing 31. We're ending on the shortcut.
Yeah.
All right, how do we set up the shortcut?
2
X cubed, 3x squared, 6x, 6.
And 0. I like it, but yeah, I guess we don't even need 0. I like it. And then e to the -2x, and then what are the integrals of those?
Half e to the -1/2 e to the 2x.
Nice. And then
1/4.
and then -1/8, right?
Yep.
Ew. All right, there we go. And then you just got to join them with the positive or negative. So this is positive, this is negative, this is positive, this is negative. So all of these are going to have minus signs then, because the things that are positive have a negative on them, and the things that are negative or negative have a, you know what I'm trying to say. -1/2 x cubed e to the -2x minus 3/4 x squared e to the -2x minus 6/8 is going to become 3/4 x e to the -2x minus 6/16 is going to become 3/8 e to the -2x plus c. I love how it says on this problem, use tabular integration. Tabular is the shortcut, or another method to evaluate this. That means if you use another method, you are literally doing the long way 3 times.
Oh,
Like, who would do that? Wait, this is not number 40. What am I even doing? What in the world? I just can't even handle my life. Okay. But I'm putting a number 40 on here. Oh, for you guys later. There we go. I'm gonna add a 40. We can some stuff. Okay. Any questions about today? How do you guys feel? Hopefully that was a little less fast than yesterday.
that's good.
Pretty good.
Sweet. Stopping recording.